All right, this whole next section is about solving polynomial equations in the factored form. Okay, so the first thing we want to look at is our first little rule, and that is zero product property. Okay, zero product property is when one side of an equation is a polynomial in factored form, and the other side is then equal to zero. This is called the zero product property. Okay, the solutions to this problem we're going to end up calling them roots. Okay, so here's where it kind of comes from. If the product of two real numbers is zero, so say a times b, if it ends up equal to zero, then at least one of those numbers must be zero. So, and then here's what I just said there. If a and b are both real numbers, a times b equals zero, then at least either a or b must be zero. Could they both be zero? Absolutely. But we want to make sure that that kind of sets us up. If you look up here, you'll notice standard form. Standard forms can be written in the form of normal monomials, binomials, trinomials, polynomials, those kind of thing. Whereas factored form is going to be more abbreviated here. Okay, so you have like x minus 3, x plus 8. These are kind of broken up more. Okay, so let's look at some examples and how we can kind of solve these using the zero product property. So first example, example 1, solve the equation here. So they took this binomial and this monomial and they're multiplying together. And they're setting one side equal to 0 because we got everything on one side, everything else on the other is 0. So first thing we're going to do is, because this is a product of each other, we can set them each equal to 0. So you have 2x equals 0, and then you have x minus 4 equals 0. Now go and solve them. Divide this one by 2 on both sides. It gives you x equals 0. Add 4 to both sides on this one, you get x equals 4. So those are your two roots for that problem. Those are your two possibilities. On the other one, they're going to go back and check those in there and make sure those work. Okay, you can plug them back in, they both work. On this one here, letter B, you're going to do the exact same thing. Okay, x minus 3, they're a product of each other, so we're going to go ahead and set one equal to 0 and then set the other equal to 0. So when does x minus 3 equal 0? Well, we add 3 to both sides, it gives you 3. Add 9 to both sides, you get 9. Again, we're going to plug them back into the original and make sure they work. And in this case, when you do that, it ends up working again. All right, close that one out. Next one, example number 2. Solve each equation here. Now notice these are very similar. So you have 2x plus 7, you have 2x minus 7. The only thing difference is the plus and minus. So just like your special case, this is a special case also dealing with solving for roots. When you set these two problems up, you'll notice that the only thing difference is that you'll get whatever you get for one will be the same for the other problem. The only difference will be one will be positive and one will be negative. So notice they subtracted 7 from both sides, divide by 2. Add 7 to both sides, then divide by 2. So you get the same answer, one positive, one negative. All right. Letter B, this one's going to be the same thing multiplied by itself. So if it's the same thing you're setting equal to 0, won't it be the same answer? In this case, it will be x equals 1 for both. And the last but not least, letter C, you can also have 3 factors. Okay, so you can set them all each individually equal to 0. Only have you set them equal to 0, x plus 1 equals 0, x minus 3 equals 0, or x minus 2 equals 0. Solve them all, get your answers, and those are your roots. You can check all those. If you want some practice for 1 and 2, here you go. Just give you an idea. Get the roots for those. Freeze it if you want. In 3, 2, 1. Okay, those are for you. And if you want some more practice with the other ones, little special cases, you can freeze it. 3, 2, 1. Check those off. All right, example 3. Factoring out the greatest common monomial factor from 4x to the fourth plus 24x to the third. So what do these two problems share in common? Well, you'll notice that they both have coefficients out front. One's 4 and one's 24. So to me, I think of the factors of each one, and whatever the greatest common factor is, that's I'm pulling out. So look for numbers. Factors of 4 are 1, 2, and 4. Factors that they share in common, the biggest one, they both share 1, they both share 2, they both share 4. but take the biggest one. So I'm going to pull out a 4. As with the variables, I'm going to pull out the ones they share in common. Well, this one has 4 x's, this one has 3, so they share in common at most 3. So I'm going to pull that out. So we're going to pull out a total of 4x to the third out, and then we're going to use the distributive property to kind of write the rest of it, the rest of the factored form. So you'll notice we pulled the 4x to the third out, and what's left? 4x to the third times what gives me the original problem of 4x to the fourth, and that's just x. And then 4x to the third times what gives me 24x to the third, and that's a 6. So you notice we actually now have, we're back to the same spot we were before. We have a factored form, we have a factored form, set them both equal to 0, and we can actually go and solve these if we wanted to. Okay? All right, here's one for you to try. Factor out 8y squared minus 24y. Pull out the greatest common monomial factor. All right, you go ahead to freeze it. 3, 2, 1. Here's your answer. Okay. And then the last example right here. Solve 2x squared plus 8x equals 0 and 6n squared equals 15n. Okay, so in this situation here, we're going to try to pull out a common factor here, which I think is what, 2 and x. Okay, pull that out, 2x. So then 2x times x gives you 2x squared. 2x times 4 gives you that. Those are your factored forms. Okay, then we're going to go and find our roots. Divide by 2, so you have the roots of 0 and roots of -4. So that would be your two possible solutions. Okay. We'll get to graphing a little bit, but these numbers will tell you a little something about the graph too for that binomial there. Do the same thing for letter B. Okay. Only difference is you'll notice that you have 6n squared on one side, you have 15n. You got to put all of the terms on one side and then set it all equal to 0. That's how you have to do the zero product property. So they're going to subtract 15n from both sides. Now we can pull out the common factor there. That's a 3n. 3n times what gives you 6n squared? That's 2n. And 3n times what gives you negative 15n? That'd be -5. Set them both equal to 0 now and solve. You get n equals 0 and n equals 5 over 2. All right. And the last one for you to try, give yourself some practice. Go ahead and freeze it, and I'll give the answers in 3, 2, 1, answers. Hopefully that gives you a little more insight into how to find roots. You notice the GCF looks very similar to, or sorry, greatest common monomial is very similar to distributor property, at least I say reverse distributor property. Let me know if you have any questions. I'll see you in class.